All right, let's go over exam two solutions. So you should still have this, and I return this to you, but if not, well, here it is. Let's do number one. Prove the following. Okay. All right, so let's prove that cosine plus tangent times secant, or times sine, is equal to secant. So pick a side. Obviously, you want to choose the left because it's more complex. So I want to make this turn into secant. So first step is use the fact that tangent is equal to sine over cosine, then multiply by the sine. I believe we call that quotient. Okay, multiply it out. You get cosine x plus sine squared x over cosine x. So at this point, you just want to add the fractions. This is a fraction, this is not. So change this into something over cosine. We need the LCD of cosine on the bottom. So you're going to multiply the top and bottom by cosine. And then you can add this piece. So this will become cosine squared over cosine plus sine. Now they have the same denominator, so you can add them together. So this will become cosine squared plus sine squared over cosine. So you should see that this right here is 1 by the Pythagorean identity. Pythagorean identity says that sine squared x plus cosine squared x is equal to 1. Okay. So 1 over cosine is secant. And that's what we wanted to show. The reciprocal property. Or I think we call them identities. I don't remember. Identity. Yeah. So whenever you see a tangent, try to change it into a quotient or a ratio. See if that does anything. Multiply stuff out. Add fractions whenever you can. Once you do, see if something happens, which it did. And then we should be almost done at that point. That's number one. All right, number two. Sine x minus pi is equal to negative sine. So obviously we'll start on the left because this looks like a difference of angles. We can do some difference, sum difference. Then we'll start right here. And then just apply your formula. Actually, I don't have that memorized. Let me find it. Okay, here it is. Sine A cosine B minus cosine A sine B. So my A and B are right here. So this will be sine X, which is the A, cosine B, which is the pi, minus cosine A, which is the X, times sine B. Okay, let's start writing better. Okay, so this will be sine X times cosine of pi is -1 minus cosine X times 0. Sine pi is 0. So you're left with negative sine. That's it. Just use the sum and difference formula. Number 3, I think, turned out to be a lame question, so I gave everyone credit for that, even if you did it wrong. I told you I would only give you things that are true, and that one was false, which I thought was annoying. So don't worry about this one. Okay. Let's look at number 4. Okay, number 4, cosecant squared x minus 2 is equal to cosine 2x over sine squared. So let's see, which side should we choose? It looks like the double angle would be the one to go with. Because well, I think it's going to be about the same. It doesn't matter. I'm going to start with the right-hand side. So this would become, to use your double angle, you can use 3 different ones. I'm going to go ahead and use, what was it? I think it's, shoot, 1 second. Okay. There's 3 different ones. I gave you a list of them. This is one of them. Cosine 2x is equal to cosine squared minus sine squared. So separate the fraction at this point. That'll be cosine squared x over sine squared x minus sine squared over sine squared. These cancel, leaving you with a 1. This is technically cotangent. Cotangent is equal to cosecant squared x minus 1. And then you have that other 1 right here. So this becomes cosecant squared x minus 2. There's many ways to get it here, especially for number 4, but that's the truth for any of these. All right, let's do number 5. Okay, so given cosine x equal to negative 2/3, and x being between pi over 2 and pi, I wrote that kind of weird. Find sine 2x and cosine 2x. The first thing you should do is find sine and cosine. So you have you have cosine right here. So build your triangle. Adjacent over hypotenuse. This is quadrant 2. So cosine is negative, as we already knew. Right? Find the missing side. That will be, let's see. So a would equal c squared minus b squared square rooted. A will be square root of 9 minus 4. Anyway, this part is whatever. You've done Pythagorean a lot. So you got negative 2, root 5, and 3. Okay. So in order to find sine and cosine 2x, you're going to have to find your regular sine and cosine. Okay, so now that you have that triangle, we know that sine x is equal to square root 5 over 3. And we were given this guy negative 2/3. So sine of 2x is equal to 2 sine x cosine x. So that will be 2 times square root 5 over 3 times negative 2/3. To multiply all this garbage, you get 2 times root 5 times that'll be negative 4 root 5 over 3 times 3. That'll be sine 2x. Cosine 2x is equal to cosine squared x minus sine squared. Remember, you can use any of the 3 double angles for cosine. This is the only one that I have memorized, so I use that one. Okay, so this will become negative 2/3 squared, that's cosine, minus square root 5 over 3 squared. So this becomes 4/9 minus 5/9, negative 1/9. That's it. Okay, so we're still gonna need this information for number 6 because it uses the same information. The only thing is you have to decide which quadrant. So let's go ahead and draw this triangle on the next page. Okay, so number 6 is sine x over 2 and cosine x over 2. To find those guys, they gave us cosine and they gave us the location, right? But if you divide everything by 2, half of this is a quarter, right? Because we're doing half angles, x over 2, then you should have an x over 2 over here. So in other words, divide everything by 2. Then you'll get the new period for the half angles. Okay. So now this is going from pi over 4 to pi over 2, which is quadrant 1. This was originally quadrant 2. Now we're in quadrant 1. Okay, which means your formulas for sine x over 2 and cosine x over 2 is going to be positive for both. Okay. Also, we found sine x earlier, same stuff. Would be, assuming that x is right here, square root 5 over 3, and cosine x is negative 2 over 3. Now it was given, right? Now sine of x over 2 is equal to plus or minus the square root of 1 minus cosine x over 2. We're going to choose the positive, so we don't have to write it anymore. And then plug in the cosine. So 1 minus negative 2/3 over 2. Add these two fractions, that'll be negative negative, so that'll be 1 3 over 3 plus 2/3 over 2. Once you get the common denominator up here, then you add those together and you get 5/3 divided by 2, which is 5/6. If you want to keep going, this will rationalize into square root 30 over 6. But this is good enough. Cosine x over 2, almost the same thing. Plus or minus the square root of 1 plus cosine over 2. Okay. So this will become, this is a positive because cosine and sine are both positive here in quadrant 1. So just add your angle, add it together. This will be 1 minus 2/3, which is 1/3, so that'll be 1/3 over 2. which will be 1/6, which is square root 6/6 once you rationalize. And that's it. We got the half angle for cosine and sine right here. Okay, number 7. Well, I guess number 7 and 8 are the same question. Solve on one period, 0 to 2 pi. So divide by 4, that gets us to here. That reduces. Square root both sides. That'll give you the plus or minus part. So then cosine x is equal to plus or minus 1/√2. Once you rationalize, you're going to get square root 2/2, which is the angle on the circle, or the value. You've seen this before. Right, that's going to happen at 4 different places because it's plus or minus. So on the circle, x will equal pi/4. Let me pull out the circle so you can see it. All right, here it is. The square root 2 for at cosine is the x value. So pi/4, negative because it's plus or minus, 3 pi/4, 5 pi/4, 7 pi/4. Now we don't keep going because it said solve from 0 to pi. So we stop right before a full period. So there's only 4 answers. So 5 pi, 7 pi, 3 pi, pi, all over 4. Number 8. Number 8 says sine squared x plus sine minus 2 is equal to 0. So this is a factoring type. See, it looks like a quadratic. So let w equal sine and then just factor a normal. If this helps you, do the substitution. If not, just do it straight up. I don't care. So you will get w squared plus w minus 2 equal to 0. This will factor like so. Plus 2 minus 1. So w plus 2 equals 0. W minus 1 equals 0. So w equals -2 and w equals 1. But w is made up. So bring back your sine. Sine x will never equal -2, so this has no solution. This will happen at only one spot. It's going to happen at pi/2. That's it. That's one spot. So x equals pi/2 based on your unit circle. So only one spot, only one solution. Okay, so that's 7 and 8. 9 and 10 is just the same thing, but find all solutions. So all you have to do is tack on the 2 pi k. So for number 9, it's the same question as 7, right? Just take each part. We'll do that next page, I guess. So just take the solutions from the previous page. So the first set, x1, will be pi over 4 plus 2 pi k. Second one will be 3 pi over 4 plus 2 pi k. X3 will be 5 pi over 4 plus 2 pi k. Fourth set will be, I believe it's 7 pi. I have a double check here. 5357, yeah. 7 pi over 4 plus 2 pi k. So all the solutions from before. You can also technically combine these all into one. Where k is a real number. I'm sorry, an integer. Technically, you could have said x is equal to pi over 4 plus pi over 2 k, right? Just jump from here to here. It's 90-degree jumps. So you can sum it all up into one if you want. From here to here's pi over 2, pi over 2, pi over 2. If you look at your circle, it's should be clear, right? From here to here is pi over 2, pi over 2, pi over 2. So I can do pi over 2 forever and still land on those 4 spots. So you can sum it up like this. Number 10. Number 10 was just one solution for this guy. So just take that solution, pi over 2, and add the 2 pi k. That's it. So that's what I had to do for 9 and 10. So if you got 7 and 8, you should have got these automatically, I hope. But anyway, that's test 2. Let me start test 3 in a bit.